got another exam walkthrough from Work, Energy and Power. This is going to be 2025 June, question number 14. So the brakes in a car reduce the kinetic energy of the car. An electric car, some of this energy is transferred to the battery in the car. An electric car of mass 1800 kg moves at a speed of 40 meters per second up the hill. The driver applies the brakes to stop the car and get rid of all that kinetic energy. And during the braking, the vertical displacement of the car is 0.76 meters and the energy stored in the battery increases by 54 kilojoules. So we can see some things happening here. We can see that the kinetic energy is going to decrease to 0. So all of this kinetic energy is going to be converted into two things. It's going to be converted into the MGH, the gain in MGH, so the gain in GPE, and it's going to be converted into the energy of battery. So it's going to be split between two of these things. So I can say that the KE is equals to MGH plus the energy gained by battery. And if I want to be a bit more specific, I'm going to write the loss of KE and the gain in MGH. Okay. Now, I have the speed, I have the mass, I have pretty much everything here. Now, what I'm going to be doing is I'm going to be subtracting the value of the loss of KE with the loss of the gain of MGH. So I'm going to have mv square minus MGH is equals to energy gained by battery. Energy that should be gained by battery. Should be gained by battery. So I'm going to take the m common out. So I'm going to have p square minus gh. So I'm going to do 1800 half 14 square minus 9.81 and 0.76. Okay. So that's going to give me 1.594 times 10 to the power 5 joules. So this is the energy that should be received by the battery. But in reality, the battery only gets 45 kilojoules. That means out of this energy also, some of the, or quite a lot of the energy is lost, probably due to friction or due to work done against drag force. Okay. So I can say the kinetic energy also is going to be split into, it's not only going to be MGH and energy of battery, it's also going to be work done against other forces, such as the drag force, or the kinetic energy is converted to other forms of energy, okay? So this should be the energy that the braking system should get, but it gets this much. So this should actually be the input, and that should be the output. Right? So this should be input energy. After we get rid of the MGH from the KE, that's the leftover energy we have. So I subtracted both of them. I have the leftover energy, and that should all go into charging the battery. So that should all be the input. But some of them, that is lost. Okay. So we're going to just divide both the values now. So 1.594 times 10 to the power 5 over 45. I think that's 45 point. Yeah, okay, just 45 times 10 to the power 3 times 100. So you're going to get 28%. So a quick summary chart. So our KE here will be converted to, some of it will be converted to GPE. And after that, so after our KE has converted, some of it has converted to GPE, not all, some. The leftover energy that we have, that leftover will be converted into charging the battery. But we notice that this input energy that is supposed to charge the battery, a lot of it is lost to other forms of energy. Okay, so that's a quick summary or recap of the question, because this is a quite a tricky question, and it is repetitive as well.